In this chapter 11, we will talk about virtual reality. So, virtual reality or VR immerses user in simulated environments for a transformative experience. While going to shopping malls, you must have seen they'll give you some headsets, and you are supposed to wear those headsets and see a movie. When you're watching that movie, you are completely immersed in that environment. For example, there would be a roller coaster, or there you must have seen a jungle visit, and there's so many different movies. The dinosaur, as if you're walking around a Jurassic Park. That is basically an application of virtual reality. It creates a sensation of being in a different place or world altogether. It cuts you from the reality. Now, it adapts to technological advancement while maintaining its foundational concepts. Rapidly evolving VR has applications in gaming, training, and education. So here you see you get the headsets, you can have the uh, you can and you can see this glasses where you are forced to see something that is being shown to you. You are only hearing is being uh, what sounds are being played around you. So input devices are basically a 3D mouse which you need to interact with the virtual world. Then output devices, you can see the LCD shutter glasses in which you see the environment. So it represents the virtual world and its effect to the users, generating a sense of immersion. Software is required to play a crucial role, for example, for data analysis and generating feedback. If you move your face towards left, the entire environment seems to pass out onto the left. So it takes the feedback and generates the environment likewise. So it controls and synchronizes the entire virtual environment. The different types of virtual reality, non-immersive, fully immersive, and semi-immersive. Although they are very much clear from the name itself, but let's see one by one what it means. So, to begin with, virtual reality and virtual environment are often used interchangeably. Both terms describe computer simulated worlds but have distinct origins and implications. They share a foundation of environments created through computer simulations and not physical matter. So it's all a simulated world. Simulated means an artificial world where we create. These systems use simulations and transducers to create perceptible experiences. Experiences include visual, auditory, and tactile sensations, enhancing immersion. For example, if there is rain happening, so you'll feel some water droplets on your hands, something like that, to make you as if you are completely a part of that environment. Now, virtual reality emphasizes immersion. It aims to completely envelop the user in a simulated world, isolating them from the real world. Virtual environment is a term that often highlights interactive aspect of the experience. So we interact with the virtual environment during the experience of virtual reality. So like VR, a virtual environment produces a simulated space. Computer graphics plays an important role in virtual reality. But first, let us now understand what computer graphics is before we take virtual reality again in detail. Computer graphics create, manipulate, and present visual information. Applications that include user interfaces, commercial, ads, movies, engineering designs. It handles both 2D and 3D images. Interactive graphics enable user to control and have real-time updates. Visuals simplify complex information for better understanding. It is rightly said that one image is equal to 1,000 words. So computer graphics can be generative graphics, image analysis, or cognitive. Generative graphics is used to create lines, circles, and ellipses. Image analysis is used to generation of pictures or images. And cognitive is used for photographic images. How to get started in computer graphics? So if your mind is very creative and if you're good at drawing and creating animations, you can understand the basics. First, choose your area of interest, whether you want to go for animated videos or image creation or generate graphics or cognitive. Then learn programming, learn how to use a graphic software, study and practice, create a portfolio of your work and apply. uh, for jobs in computer graphics. So application of computer graphics include computer-aided design, computer art, presentation graphics, entertainment, education and training, and visualization. Real-time graphics is, as the name suggests, renders 3D data instantly for animations. It provides interactive and immersive user experience. So when you are working with virtual reality, 3D graphics are, and basically to be more specific, real-time computer graphics is used to create that immersive experience. The technology focuses on instant messaging generation and processing. Applications include GUIs, real-time image analysis, and interactive 3D visuals. For example, when you have a PlayStation, you're playing a game. So it is an interactive 3D visual. It is also used, real-time computer graphics is also used for creating dynamic responsive environments. For example, if you want to train somebody how to drive a car, so you can basically use such a simulated environment. Even in many places, including in India, we have driving tests in a simulated environment. Then real-time rendering. Again, as the name clarifies, it is the process of creating computer graphics requiring quickly enough to be displayed immediately as they are generated. Real-time 3D rendering is widely used in video games, virtual reality, and other interactive applications. For example, in medical imaging, it is done, and you can see it the output on the screen. Scientific modeling, designing, prototyping, and 3D modeling. Oil, geology, and mining, architecture, and virtual tours of a particular place, and then military applications. So here you see what real-time rendering is. So here is a picture. We create images and then how it works, let's see. So it's a three-step process basically. The first step is geometry processing. In this, the program generates a 3D representation of the virtual environments or objects by defining the geometry is defined. Second, shading involves calculating lighting and shading effects for every pixel. So calculation is done for shading, and here rasterization. During rasterization, textures, colors, lights, shadows are added to the design. Rendering process optimization. To optimize the process, first let's learn about quality reduction. Lowering the quality of the 3D model and texture can significantly reduce computational load. Simplify, so less the quality of data that is required. That is why we sometimes ask whether this particular application will be required for a low resolution purpose or high resolution purpose, right? So simplifying models and using low resolution textures help maintain performance while preserving visual fidelity. Pre-baked texture maps. In this, some pre-processing is already done to reduce the need for real-time calculations. So if the pre-processing is already done, so that saves your time basically. You can quickly render that image or graphics. So this involves pre-computing and storing complex lighting effects such as shadows and global illuminations in textures that are applied to 3D models. Then level of details. It dynamically adjusts the complexity of 3D model based on their distance from the viewer. Obviously, when you go far, you see less details. When you go close, you see more details. So that things need to be processed. Shadow clipping. This means that only the visible parts of the scene are rendered. Ray tracing. While computationally intensive, ray tracing enhances visual realism by simulating the way light interacts with the surfaces. So here is a comparison between pre-rendering and real-time rendering. Pre-rendering, when calculations are done in advance, and real-time, it is done on fly as and when required. High level of detail and realism is possible because most of the calculation is done beforehand. Here, low level of detail. Time and resources, it can take hours, days, or even weeks. Quick, but here you don't have time because it has to be displayed in real time. Interactivity is limited because it is pre-processed, so there is not much scope for interaction. But here, real-time rendering has high interaction and therefore it is used in video games and virtual reality. Quality versus speed. Pre-rendering prioritizes quality over speed, but it is the opposite in real-time rendering. Pre-rendering is suitable for highly complex scenes. It is suitable for interactive experiences. Common uses of pre-rendering is movie, high quality animations, and visual effects. Here, common uses is video games, virtual reality, and interactive media. It is not adaptable once rendered. For pre-rendering and real-time rendering, it is adaptable because it is done as and when required. So you can make changes to the scene. Here, examples include CGI in movies like Avatar or Toy Story. Here, games like Fortnite or VR experiences. Other applications of real-time rendering include video games, virtual reality, augmented reality, architecture and design, film and television, e-commerce, education and training. For example, flight simulation. A flight simulator replicates the flying environment for training and recreation. It enables pilots to practice safely in a so it's basically for pilots to practice safely in a controlled setting. Flight simulators reduce training costs and risk compared to real world flying. They assist in aircraft R&D by testing designs and control handling. These systems enhance safety and envision and efficiency in aviation. For example, here this is the pilot. He wants to fly and he wants to fly or he wants to land. Then he presses and holds the button. If he wants to fly, he has to press and hold the button. Then airplane takes off and then it feels as if the pilot is flying. Now, when he wants to land, he releases the button and the airplane starts landing and he could feel that landing. So this is the basically the overview of how it works. And the system contains multiple displays to provide a realistic visual environment. There are control devices like joystick to mimic the aircraft's control system, audio system for realistic communication and sound effects, and a computer system to process control input, simulate flight dynamics, and record flight data. Virtual environment requirements include realism, so accurate representation of aircraft instruments and external conditions. Interactive, user must be able to interact with the cockpit controls, external conditions, and scenarios. Provides immersion with high quality graphics, sound, and interface designed to create engagement. Feedback mechanism for real time auditory and visual cues to simulate in aircraft responses, and then it should be accurate to reflect the physical and operational characteristics of aircraft and the environment. Now, specific requirements of different visual environments include augmented reality. Augmented reality is a technology that overlays digital information such as images, sounds, or other data on the real world in real time. We are already using augmented reality. Can you guess where? If you have used Snapchat app, so what we do is you take your own picture and then you superimpose some accessories, some dress on your image, right? Or you change the background. You're sitting in a room, but the background would be as if you are sitting next to Eiffel Tower, right? So that is augmented reality, which overlays digital information onto the real world in real time. Virtual reality creates immersive, interactive, and computer generated environments. And mixed reality is a combination of both AR and VR. Let's understand the difference between AR and VR. While augmented reality enhances real world scene, virtual reality creates a completely immersive virtual environment. So here the user is totally cut from the real world. But in augmented reality, user is a part of the real world. Digital objects are added on real data, right? It users remain aware of the real world. Here, users visual senses are controlled by the system. Real versus virtual, augmented reality is 25% virtual and 75% real. This ratio is opposite in terms of virtual reality. So, augmented reality gives a partially immersive experience, but virtual reality is a fully immersive experience. The bandwidth required for augmented reality is 100 Mbps. It is compared less in case of virtual reality. So, in augmented reality, you do not need any specific AR headset, but you require a VR headset to have a virtual immersive experience. User interaction with virtual objects takes place in the real world, but in virtual reality, users are isolated from the real world and engaging in a fictional environment. Primary use of augmented reality is to enhance both real and virtual worlds, but Virtual reality enhances fictional reality primarily for gaming. Benefits of virtual reality, as we've already discussed, provide immersive learning experiences, risk-free practice, especially used in training sessions, provide personalized learning experiences, enables hands-on learning, offers flexibility and accessibility, reduces cost and environmental impact, improves retention and recall, enhances collaboration and communication, provides safe learning environments, prepares students for future careers, fosters empathy and understanding. Real life application include gaming and environment, training and simulation, education and learning, healthcare and therapy, architecture. You can even, there are many AR and VR apps where you can do yoga, practice yoga with the help of a trainer, yoga trainer in the virtual environment. So you can have a totally virtual environment where you can get instructions and work according to the instructions given by the virtual trainers. Then it is used in architecture and design, engineering and manufacturing, tourism, hospitality, to get before even there are apps. Suppose you want to go to Manali but you've never been there, so you can use the headset to create a virtual environment where you are moving on the roads of Manali, experiencing the snow, so that you decide whether you want to go there or not. Rehabilitation and physical therapy, especially those facing from mental disorders and traumas, can get benefited with this technology. So this was all about virtual technology, virtual reality. In the next chapter, we'll read about other emerging technologies.